Okay, so this is an update for MainBrain. I've been writing a lot of code. I got an operating system going. I think it's pretty much done. The framework's done. There'll be some details to hash out, but this is the basic idea of it. MainBrain is designed to control other things, like it can control anything. It's made to stack on top of interface boards, and you could do almost anything with it, but I intend to run a robot with it. So I needed a fast processor and fast communication. So one of the key things with MainBrain is a dual port RAM. So the main processor here is going to write to the SRAM, and the interface board will have probably a DSP processor that will control the motors, and it can read and write to the same memory, and they can communicate back and forth at a pretty high clip. MainBrain runs at 80 megahertz, and in fact we'll start the menus here, and we'll go to the oscillator, and the oscillator shows, this is a screen that shows a little bit about the oscillator. MainBrain's running at 80 megahertz, primary oscillator, and then all the peripheral clock that controls the speed of the communication with the other peripherals on the board, well, internal to the processor, are also running at 80 megahertz. So it's moving along pretty good. The secondary oscillator is enabled. That's the real-time clock. It's not locked from reading and writing right now. USB, I might take that out because we don't use the USB on the chip. So we have the OSCON here. That's the oscillator control register. It gives you the data 32 bits in hexadecimal format, and that helps with debugging and stuff like that when you write more code. Alright, and then you just press home, you come back to the main screen. So now MainBrain can run on 5 volts, maybe under 5 volts, but 5 volts to 12 volts is what it's geared to run at. So as the input voltage rises, the voltage regulator has to drop a lot to keep MainBrain running at 3.3 volts. That's the main voltage of the board. So the voltage regulator can get hot. So MainBrain keeps an eye. It measures the temperature of the regulator, and the regulator is also, it's current limited. It can handle up to 1.5 amps, but to handle 1.5 amps, you'd have to have a pretty big heat sink. But so MainBrain monitors the temperature. Right here, it uses a DS18B20 chip. So we'll go to the menu right here. It takes about 1 second for it to measure the voltage, and it's a single line serial communication, so it takes a little while. So basically we have the temperature right here in degrees C, and the serial number of the chip that measures the temperature, and it's a family 28, which is a single wire communication chip. Alright, go back to home. Now the current, MainBrain also monitors the current that the board uses, and as you interface more cards and you use MainBrain's 3.3 volts and also input voltage, it measures the current. And so right now we only have MainBrain itself and the display. The display is at full brightness right now, so it's going to be the one that drags the most current. So we'll go right here to the current, and then it plots it on the screen. Right now it's pretty much flat lined. As you ramp down the brightness, since it's a PWM, it's a square wave, so you're going to see a band of current being used. But right now it's full screen, no square wave, and so it just sits there. The peak current is 297 milliamps. All right. Now we see the display menu. So it tells the part number, the type of the display. It's a TFT. This is the part number. It's a 320 by 480 pixel. 480 this way, 320 this way. You can rotate the screen through software. Right now it's in 16-bit mode. They call it 16-bit 565 RGB. This is the device ID. Brightness at 100%. This tells the touch. This is the touch screen coordinates. So right now, when it's just sitting idle, it's at maximum. So that would make it over here on this corner. But it reads it real time where you put your cursor. So right up here. Right up here is 0. Right down here is maximum. And then your in-betweens. Alright. Then we have the real time. That's the secondary oscillator. So right now I just have it set so it just resets when you reset MainBrain, then it starts at 0. So it's been 32 minutes since the last reset. I'll probably do an accumulated runtime later. And then we have SRAM. This is the dual port RAM. It's not the internal SRAM to MainBrain's processor. This is external on the board over in here underneath. So the SRAM menu comes up and it tells it you're in SRAM, and there's 1024 8-bit words in there, and it passed test. It says okay, it passed test, and then it shows 1024 little squares here, and if there's a bad one, if it fails test, it'll turn red. All right, and you can see that it doesn't take very long for it to do the test. The SRAM's fast. So then we have external flash as well, a 1 megabit flash, external flash memory, so that you can save code on there and then load it later. MainBrain's processor has 512K of its own for this program, and this program's using about 30% of it right now, maybe 40. All right, let's go to the flash. Takes a little while to go through, and it counts how many bytes are non-zero, or I mean non-zero. FF hex is actually an unwritten value, so it checks to see how many values have actually been written to, and right here it's in hexadecimal. It's approximately 55,000 bytes that's used up right now. And so it tells it's a 1 megabit, but it's a 64K by 8-bit flash, and this gives the manufacturer ID and then the device ID. And that helps in programming sometimes. Some different flash will have different write times and erase times and stuff like that. So then we can erase it. So if you hit erase, it'll erase it. So now there's 0 bytes used. And we can come back. Okay, so the last one, last but not least, is the serial port. So we're using a CP1209 chip, and it is a USB to UART bridge. So it's USB from the PC, but it actually behaves like an old style serial port. So this is what we got here. That's the device, the chip part number. Right now the baud rate set at 57600, like the old Hayes 56 flex modems. Data bits, 8 data bits, and 1 stop bit, no parity. Okay, so then it has a button here called Get File, and that's going to be a part of a separate video, because you can download a file into the flash. So you can download a file up to 64K and store it in the flash. And so later I'll use the download also as a bootloader, so it can update the firmware in MainBrain, but I haven't got that far yet. All right, and there's MainBrain, and we'll get an update later on.